Finally got a new microphone, so hopefully my audio doesn't suck as bad as it previously has. Anyways, so I want to talk about some common things that you have at your disposal if you want to kind of hack your 3D printer, or if you're going to be making modifications or using your 3D printer as a platform for something other than just 3D printing. Um, right, so what you're going to be doing is a lot of repurposing, right? So you've got control circuitry on your control circuit board that can do various things. Namely, the things that we're most concerned about are things like digital input and output, analog input and output, and serial input and output. If you have all of those, you can pretty much do anything you'll ever need. Um, so we're going to look at those kind of within the scope of a typical 3D printing system. Yeah, so the first thing you might want to look at is your limit switches, right? So your limit switches are they're essentially digital inputs, though they're not. Well, it varies from system to system, but normally what these specific inputs are looking for is a closed contact, um, and so you can you can actually just feed in whatever it's expecting, either a zero or a one, um, into the input. That's something that is possible. But if you have trouble with that, something you can consider doing is using a relay, like what's pictured here. Just a real quick recap on how a relay works. If you provide power on this coil, it acts like a magnet, and that magnet causes this to either attract or repel to push these contacts together. Um, and so that is closing a contact, and that's all that's happening in a limit switch, right? Is we're closing a contact, meaning that two pieces of uh, conductors are now touching, and that closes the circuit. Um, but you do have to be careful if you are using these digital inputs for something other than just limit switches, or specifically for like your X, Y, and Z end stops. Um, because sometimes they can trigger your firmware to stop the printer because that means that it's crashed or it's lost track of where it's at. Um, that's something to be aware of, and you can modify the firmware to get around that. Um, but something that's useful to know is that you can pull or figure out what state these inputs are at with just the M119 command. So you can see here in this output the Z end stop is being triggered, and so that might mean whatever it means to you, right? Maybe this is hooked to something that indicates if a person is standing in front of the printer. It would still come up in the Z min because once again we're hacking, so we're using things for purposes other than the originally intended purpose, um, and so that information is still there for you to interpret and use as needed. Oops, wrong way. Um, yeah, so another really useful thing that I've used a lot are fan outputs. It always seems like you've at least got one spare fan output on your control board. Um, and oh, by the way, I forgot to mention this is the Ender 3 control board. I'm not sure if it's the current one, but this is about what it looks like in there. Um, anyways, so I believe even the Ender 3 has one spare fan that can be used, and those outputs are very flexible because they can be quote unquote analog outputs or digital outputs. Um, so they're not really analog. What they really are pulse width modulated, meaning that they turn on and off at a certain percentage. They stay on for a certain percentage and off for a certain percentage, and you can indicate what that percentage is. So, for example, 20% is on 20% of the time, off 80% of the time. 100% duty cycle means that it's on all of the time. Um, and so you can vary that output, right? So you can vary your duty cycle, and by varying the duty cycle, you can affect the speed or the power of whatever is connected to it. Um, and something to consider is these fan outputs aren't made to output a lot of current, and so that means that there are special considerations when you are controlling something of higher power. Uh, And it turns out that, we'll see in the next slide, that heater outputs are pretty much this, well, with some caveats, they're pretty much the same as fans. They're still PWM outputs. But something else to consider is using a solid state relay, something that I'll show you later. But controlling these fans is reasonably straightforward. Fans are open loop devices, meaning that we don't have a feedback, and so all you have to really do is say, use an M106 command, and you indicate which fan you're trying to control and what duty cycle you want. And so actually, the duty cycle, it's a byte, meaning it's 8 bits, which is values ranging from 0 to 255. So all that means is 0 maps to 0% duty cycle, and 255 maps to 100% duty cycle, and that's just kind of a linear mapping there. So yes, so like I said, you can use these analog outputs, so we can do anywhere between 0 and 255, or we could just saturate them, meaning 0 is off, 255 is on, in which case it's acting like a digital output. Yes, so heaters are PWM outputs just like fans, except this good thing is that they can source more power. You can see underneath this heatsink is likely some sort of switch, like a transistor, that allows it to output more power. But, I should probably put that as a but there, they rely on feedback, which could be a good thing. This doesn't necessarily have to control a heater. This could be controlling all sorts of things. No examples are specifically coming to my mind, but you can have all sorts of closed-loop control systems that, as long as you can control them with a PWM and read the feedback in some analog way, you could hack this in order to do that. So that can be nice. But if you want to have it operate in an open-loop fashion, things are going to probably not work like you want, because you can't indicate the PWM out on this. All you can do is indicate the temperature, and so that's definitely something that might take a lot of working around if you don't have a feedback there. And the other thing, like I said, all your G code is going to expect your units to be units of temperature, right? So usually Celsius. And so your units may be something else. But that's just kind of a result of the fact that we're kind of getting hacky. We also have our motor outputs. And so really the motor controllers don't care what steppers they're tied to as long as they can output enough current to drive them. And so that means, right, if you're using like your 3D printer is an XYZ platform, right? So you've got XYZ, that usually leaves your extruder open to use for some other motor. So you can connect that to something else. But I wouldn't recommend repurposing these for anything else other than driving stepper motors, because they're driven by special circuits that are made just for driving stepper motors. And you probably could repurpose them, but it would be a little janky. Yeah, so with regard to your power supply, oftentimes you'll have more power than you need on your supply for your printer for most cases. And so that means that you can feel free to tap some power off of that as needed. But there are some cases where you might need a different voltage or more power for whatever your end effector is, right? Whatever your end process is that you're doing. In which case you need to introduce a second power supply. And usually, right, if you want to control something still with your original board, you would need to introduce something like a solid state relay. So a solid state relay is great because you can feed a PWM signal into it. The first relay that was pictured, that was a mechanical relay, and those can't really handle PWM because PWM is normally fast, and you would wear out a relay by switching it that fast. But solid-state relays, they don't have mechanical components, and they can handle PWM very well. Anyways, so what you can do with a solid-state relay is you can have your signal, say from a fan output, just going right across here. and then you can have whatever you're trying to control connected here to our contact on our solid state relay. And then we just supply a plus and a minus from a power supply. And this could be your original power supply, or in the case where you need to use a different supply, you could use a different supply. Um, and so this signal might be like just a 5-volt signal, and this could be 120 volts or any type of thing, as long as you got the right solid state relay for it. So solid state relays are a really good, easy way to interface your board to big loads, and potentially if you need to use a different power supply. Yeah, so analog inputs, this is kind of the only thing that you can really get bummed out about, is some controllers do have analog inputs, but even then, Marlin doesn't really have commands to interface with them, so you'd have to get in and modify things in order to get that to work right. But you do have temperature sensors available to you, and those are made to read resistances, because thermistors, which measure the temperature for things like the heated bed and the end effector, those are just resistances that vary with temperature. But the biggest thing to consider is that those are usually set up within the firmware to act as a feedback for the temperature controllers. And so if you're trying to use those thermistor inputs as analog inputs and your heaters as something else, there's gonna be a lot of modification involved there. And so I warn you that it's something you're gonna have to tread carefully on, because it could get really complex to go through and modify those things. Something I would consider instead doing is using serial communication. So pretty much every board, even if it's not advertised, has some form of serial communication on there. And so some boards have them broken out, so you can just immediately connect to them, but some you have to hack. So if you look at like the Ender 3, there's this connector which goes to the LCD, and some of these pins are for a serial protocol called I2C. I2C is really great for a couple reasons. One, because you can have all sorts of different things tied to that. Multiple boards can share that same bus as long as they have a different address. And so that means that you could find an I2C board that could read analog inputs. And now that has enabled this board to make analog reads. And how do you do those reads? Well, you can use Marlin 260 or the 261 command to send and receive to interface with those boards, and that information will be displayed through some sort of terminal or whatever you've got your board connected to. And so this is probably your best bet for adding a secondary board that's maybe controlling your end effector to your main control board. So we can still get G-code commands coming in here either through SD card or USB, and then you can output those through these M260 commands out to whatever you might want to. Yeah, just a hacky idea I thought to share. If this all seemed too complex to you, something that you could do that I don't see any reason why it wouldn't work. I'd never tested this specifically. Is if you have an end effector that you have to have a custom control board for, but you still need to receive commands from the printer controller, and you don't want to use serial, one thing that you could do is just use a fan output, right? So we still use that fan output that can be digital or PWM, really. And say when the printer gets to a specific destination and we need to let the end effector know to do something, we could just output a signal from this fan output, and the end effector controller could say, oh, hey, I see that signal. I must be where I need to be. I'm going to do something. So it's originally being used or intended to be used for fan, but we might be using it to do whatever end effector is doing. Maybe it's take an image because we got a camera tied to it or something along those lines. Yeah, so these are just the general tools that you're going to have available to you every time you go to hack the electronics on your 3D printer.